All dynamic languages are going to have that one trait. Many of them already do, but it's going to develop, it's going to improve, and it's going to evolve. What is that trait? How does it work, and why do they need it? My name is Andrew. Let's start. So what is that trait? Let me give you an example. We have a function called, let's create a function called createUser. So we have our createUser function, and it accepts two parameters, user and something like isRefresh. So isRefresh is gonna tell us if we need to refresh our user or if we need to do something else. So the logic itself doesn't matter. So what we can do is something like user.save, if isRefresh, user.refresh. Once again, the logic itself doesn't matter. It's just like an example, and return user. All right, so here we have our function, createUser. What is the problem with that function? Once again, the logic does not matter. The problem is that I have two arguments, user and isRefresh. But I do not know what are the types of those arguments because Python is a dynamic language. We do not have types. For example, if I would use something like C++ or Java, I would write Boolean. So Boolean is refresh. Something like user is user. But dynamic languages like Python, JavaScript, Perl, and others do not have that trait because they are dynamic. I can put anything that I want inside of my variable. That is their big advantage and their big disadvantage, because the biggest disadvantage in using dynamic types is that we do not know what is the type of the variable that we are passing in our createUser. And for example, what if instead of using my createUser with like the real, so imagine I have class user, or let me create it. What if instead of using my user in my user object in my createUser, I'm just going to pass 10 or a list 1, 2, 3, and isRefresh is going to be true for now, but you can see the problem. I can pass any data structures that I want inside of my variable, inside of my argument, inside of my thing. And what is the problem with that? Well, the most obvious problem is that if we can pass anything, the users of our code can introduce a lot of bugs that are related to the types, to the types. And the problem is that we cannot really restrict the type to just user, because we can say user is user. But what we can do is leave a comment, which is called an annotation. And annotations are the future of dynamic languages, because if you worked with JavaScript, you know about TypeScript. So TypeScript is like an addition to JavaScript that allows you to add types to JavaScript. And that might be counterintuitive. So we have JavaScript, which is a dynamic language. We can put any variable type inside of our variable as we wish. So I can put let a as 1, I can put let a as a string. Kind of like that. But why do we need to introduce types? Because in JavaScript and in Python and in any dynamic language, if we introduce types, we can remove millions of bugs. So in Python, how does it work in Python? Instead of createUser with just user and isRefresh, what I'm going to put here is user, then colon, and the type of my variable. So the type can be anything, integer, boolean, list, str, so string, but in our case, it's going to be our user. So just the type of the variable. In our case, I'm going to write the name of the class, and that is called an annotation. So that is just a comment for you and for other programmers to like really see what is the type of that variable. The same can be said for isRefresh, like boolean. What's the advantage of using that annotation? Well, the biggest advantage is that right now I know that my 1 to 3 list is not going to be working with the createUser function, because it says expected type user got list from integer instead. So my IDE knows that I'm expecting a user type, and the programmer itself knows because he sees the annotation from my argument here that points to the user. So we need to pass user type. Once again, that is just a comment. The comment that says your variable should be that type. If I put user in here, so just like that, now everything will work. So I can run it and there will be no errors. The same goes for isRefresh. So if I put something like hello here, it's going to be highlighted because the type is different. So we need to put either true or false, so Boolean value. Another advantage is that if I change the signature of my method inside of my user function, so for example, I add an argument in refresh, it's going to be highlighted as well, right here. Annotations are just comments for you to see the types of the variables. So that is a comment, that is a comment, and so on. What you can do in addition is get the return types of the variables. So what you can do is put that by arrow and then the return value of your function. In our case, we return the user, so right here, return user. And I'm just going to put the user as the type for my function return. Another example, if you still don't know what I'm talking about, is something like a sum function. So I have A as integer, B as integer, and we can return integer, which is A plus B. So now I know that A must be an integer, B must be an integer, and we return integer at the end. Once again, your Python will not restrict you from putting like a string inside of the sum function, because those are just the comments. You don't have any type validation in that case. So when you put an annotation in a function, in a method, or even in a variable, because you can create a variable with an annotation, like A integer equals 1. It's kind of useless in that case, because we can just write A equals 1 and that's going to be pretty fine. But those are just the comments. They will not be checked during our compilation, during our interpretation. So that's about annotations. But another thing that I want to show you is that you have Identic Module. Because Identic allows us to see another great advantage of using annotations. So Identic is a library that allows you to get your JSON data, so JSON data from your web APIs or some other source, and convert it to your objects. So you have your JSON data and you convert it to the objects. Imagine that you have user class and it's a base model. Model is kind of like your object. So you have users, you convert them from JSON to your Python objects to work with them, and from Python objects to JSON. So I think a lot of you know about Identic. You have your user, and what you can do here is ID integer, then username string. And as you can see, we have annotations here. So ID is an integer and username is a string. Aside from the comments that allow me to see that we need to pass ID as an integer and username as a string, what we have here in Pydantic is type checking. So I said that annotations are not useful for type checking, but in some cases. In Pydantic, for example, the creators of that library coded it, so we use our annotations as type checkers. What I can do is ID as 1 and then username as hello. And if I run my code right now, we will receive nothing, so there is no error. But if I use username as a list, for example, we can see that username string type expected. And that only happens because we use annotations here. So of course, in the Pydantic library itself, we have a lot of code that goes into validation, goes into all of that stuff. But as a user of that library, I can just put annotations and be done with it. And that is another great addition for annotations in Python and in other languages. You use annotations in order to show what is the type of your variable, and you use them in order to check for the types in some other libraries and in some other places. Kind of like that. And if you want me to tell you about typing module, you can just ask that down in the comments, because typing module is a module that allows you to get tons of annotations. So something like optional. What if you want your type to be like an optional type? So if you don't want to pass nothing, there is, I don't know, any string. There is awaitable for async operations. There is pattern, there is protocol, there are tons of things, named tuple, a lot of things. So if you want me to describe all of those, just write that down in the comments. But that's it for now. My name is Andrew. Subscribe to my channel, leave a like, leave a comment, use annotations, and bye bye.